Hey guys, Miss Pipel here. Today in this video we're going to be looking at percent composition of compounds. So here on this one we have just the basic definition that this tells us the percent of a compound that is made up of each individual element in that compound. So if we had an example compound that we broke down to figure out the percent composition and it was made of carbon and hydrogen, maybe that compound was made of 75% carbon and 25% hydrogen. Okay, the other thing that we need to know is that we do this percent by mass. Okay, so we're going to end up using the molar mass that we have practiced in class. So why do we care about percent composition? You can actually use percent composition to identify unknown substances. So there is technology that will separate a substance out into its component elements and tell you like what percentage of that substance was each of those elements. And that technology is one of them is a mass spec, which you might see on like a crime show. We're actually going to do a forensics project later on this unit that goes through where you have to identify different substances and use it to identify like who murdered who and who is who in this plane crash and all this good stuff. So you can actually use it to identify unknown substances, which is kind of cool and very practical. So this really is a basic percentage. Okay, so the percent of the element is equal to the mass of the compound that comes from that specific element divided by the mass of the compound. So percents are always part over whole. And so the parts in this case is going to be the element, and then the whole is the mass of the whole compound. And then of course we do our times 100% at the end. Okay, so if we're going to do an example, and I'm going to start that in just a second, of finding the percent composition of water, H2O. And so we're going to need to find the percent that is hydrogen and the percent that is oxygen. If you're asked for percent composition, you have to find it for all of the elements in the compound. Okay, and just so you know, the total mass of the element in the compound is the mass of all of that element summed up. So again, I'll show you that in just a second. So let's go through it. Okay, so the first thing we need to do is find the total mass of water. So we're going to do that doing our basic molar mass calculation that we have seen already. So hydrogen on the periodic table has a mass of 1.01, and according to this formula, I have 2 hydrogens. Okay, oxygen has a mass of 16 on the periodic table. There's only 1 oxygen, so that's the total mass for oxygen. And then the total mass for water is going to be in red here, 18.02 grams per mole. So that's my total. Okay, so that's what's going to go on the bottom of my fraction. So if I find my percent of this molecule that is hydrogen, I'm going to plug in the mass of hydrogen, and I'm going to divide that by the total mass of the compound, which is 18.02 grams per mole. Notice those units cancel, and I can multiply by 100%. Okay, when I do that, I should get, that is 11.2%. I'm going to keep that to just be about 3 digits, hydrogen. Okay, so I'll box that off in black to show that's what I'm looking at. And then I'm going to do the mass and the percentage of water, okay, as well. And so I'll do that up here. So I'm going to take my 16 grams per mole from oxygen and divide it by the total mass of water. And multiply that by 100%. Okay, and some of you may already know what we're going to get here. Maybe you did 100 minus 11.2, which should get you 88.8% oxygen. Okay, so the double check here is that all of your elements added together, the percentages should all add up to be 100 because we're talking about the whole molecule. So if that doesn't happen for you, that's going to be an indicator that you need to go back and check your work. So we did mass of hydrogen over the total mass of water, mass of oxygen over the total mass of water, and got the percentage for each. We've already talked about hydrates a little bit as well. So hydrates, remember, are just these molecules that have water that's found its way in the nooks and crannies of that ionic compound, and it kind of finds its way in there in a specific ratio. And so oftentimes we may be asked to see what the percentage of water is in a hydrate. So this time I don't have to do every single element. I'm going to do the percentage of water over the mass of the whole molecule. Okay, so I'm going to go ahead and really quickly get this molar mass for you, and then we'll get started. Okay, so after some quick math there, the mass of water in this molecule is 36.04 grams per mole, and then the total mass of the molecule is 170 or this compound I should say, is 170.49. So I'm going to take that mass of water, the 18, excuse me, that's not right, 36.04 grams from water, and I'm going to divide that by the total. Let's do the total in black here, 170.49 grams per mole, and multiply by 100%. Okay, and this is just the mass of water over the total. Okay, so I'm going to go ahead and do that math, and I get 21.1% water. So the mass of that compound, 21.1% of its mass is coming from those water molecules that have found their way in there. And I have one more example for you. This percent composition can be applied to any sample that you have. And so this question here says, how many grams of oxygen can be recovered from the decomposition of 130 grams of water? So water has a formula H2O. And so I can apply the percent composition that I found earlier to this actual specific sample to tell me how many grams of that sample that I have come from oxygen. And so the way I'm going to do that is, if we remember from our earlier example, our percent of oxygen was 88.8% oxygen. So I'm going to apply that percentage to this sample. Okay, so that's my percentage of oxygen. This is my grams total, so 0.888 times 130 is 115.44, and so if I were to round that to sig figs, I'll go ahead and do about 120 grams of oxygen would come from that size sample of water. So your percentage can be applied to the sample you have at hand, okay? But in order to do that, I do have to put it in decimal form, so don't forget about that. We'll do some more examples, and I'll answer any of your questions in class. Thanks, guys.